What's up? What's up, everybody? Welcome to the show. I hope everybody had a great holiday season. I'm feeling pretty good myself too. I mean, I feel excuse me. I feel okay. I got my throat's a little scratchy. It's dry. I feel like the weather has been crazy. But anyway, there's a beautiful. I'm out here. I'm outside. I'm surrounded by mountains. Like a panoramic view of this gorgeous snow-capped beauty. And yeah, today's episode is called "What Are Constellations?" And we're gonna look at what the constellations are. What are the constellations? We're gonna take a look at what they can tell us about the world we're living in, and we're even gonna touch a little bit, because I don't know if you guys have noticed on the show yet, but I take an interest in the Bible and Christian stuff. So we're gonna take a look at that, at why in the Bible did God point out the constellations? Why did he make that a big deal? So anyways, I hope you guys are good. Like I said, it's the holiday season. We just had Christmas and Hanukkah, and those are the only two that I know of during this season. Yeah. Mine was good. I'm not a big holiday guy, and then but I like doing the family thing, but my family kind of didn't do much. We just, we didn't do much this season, but it's been crazy. We're in this pandemic, or whatever. I'll use that as our excuse for this year. Anyways, we'll be right back here, and take a little break, and then we'll get into it.
Mark, T-minus 1 minute and continuing to count. A water deluge system now has been turned on, activated at the pad area. Pressurization taking place now, the various tanks aboard the vehicle being pressurized. Switching to internal power. All stages switching now to internal power. All propellant tanks being pressurized. Count continuing smoothly. The water at the pad covering the flame deflectors. Now we passed the 30-second mark. Water also will be coming on to the decks of the mobile launcher at the ignition point. T-minus 20 seconds. And the countdown continues to go smoothly. Guidance release. T-minus 13, 12, 11, 10, 9, 8. We have ignition sequence has started. 6, 5, 4, 3, 2, 1. 0. And we have a liftoff. The Skylab lifting off the pad now, moving up. Skylab is toward the tower. Houston is now controlling. 18 seconds, pitch and roll program started. Saturn now maneuvering to its proper flight path attitude. Mark, 25 seconds.
Okay, so we're gonna check out. First of all, most of us already have some understanding of what a constellation is. So the constellations are these groups of stars in the sky, and we have different historical, cultural references for them and stuff, but they seem to cross over between a lot of different cultures, and a lot of them, most of the major renditions of these constellations, as we call them, are similar across different cultures. So throughout history in different places, they would recognize the same clusters of stars as these things, and they sometimes would have different names, um, and sometimes they'd have different symbols that the constellation represents. Sometimes not. Sometimes they'd have the same ones. So, to give you an example, like some obvious ones, we've got like the Big Dipper. That's one that most people can see in most places on the Earth, and that one's an easy one because it looks like we say dipper. It looks like a ladle or a spoon or a pot or a pan or a pot, like a ladle. Um, and that you can like dip into the thing, a dipper. So that makes sense. So that's an example of what a constellation is. It's like this picture in the sky. And some of them, I use the Big Dipper as an example because it's obvious, but it looks like the thing it's supposed to look like. But what's interesting is a lot of these other constellations do not necessarily look like the thing they're supposed to be. So there's like a good example of that is the one we call, most cultures refer to as as Virgo or the Virgin. And typically the picture that they say that is like a woman. It's crazy. It's like there's like 8 stars or something. I forget what it is. Maybe like 12 stars. I'll look it up but it's basically a picture of a it's supposed to be a woman or a virgin holding like a bunch of wheat in one hand and like a scepter in the other usually. Or there's like different meaning, like sometimes it's like wheat, or sometimes it's a ear of corn. But anyways, we find that different cultures refer to that same cluster of stars as that same name, and they have different. It'll change in the details a little bit, but it's basically the same thing across these cultures. So, let's see, Virgo constellation. I'll tell you real quick. According to Wikipedia, it says that it lists the stars. I don't want to just sit here and list every star from it, but what are the major stars in the constellation Virgo? There's 15 stars named in that constellation. You got like Elgafar, Phlegetonti, Hezekiah. There's all these weird names, and there's the names are interesting too. That would be, I could get really deep into. We could get deep into looking at those, but anyways, suffice to say that something like Virgo, like I'm looking at the picture right now, and it's basically like 4 lines coming off of a 5th line, and it looks like a stick figure body without a head. And there's not a lot there when you connect these stars. It doesn't look like a virgin, but people talk about it like a virgin. So that's where it gets kind of mysterious, and we could, I could probably talk a lot about how the idea that different people had. No worries. We could talk a lot about how where those came about and where we think they came about, but it's a mystery, and I think different cultures would have different explanations of the origins of the constellations. But suffice to say, we could say all of the constellations, or all of the cultures recognize these same, again, groups of stars. So even though they have different details about what the woman's holding in her hand, for instance, they all refer to that same cluster of stars. And often even the names of the stars are similar, or can be translated back to different things. So pretty interesting, but we know that. And okay, so I think that kind of rounds out what we know about what the constellations are from a historical, cultural standpoint. In the next segment, we're going to look at what the constellations are from an astronomical standpoint. Enjoy this musical break. ready. We got the. I hope you guys like the music. I'm not even sure. Sometimes I pick the music afterwards, so just put a spot for a break, and I bet you I'd put something good in there. Okay, so next we're going to talk about what constellations are. What are constellations from the standpoint of science and astronomy? So I'm going to use numbers here, probably a lot in this segment. So the star, basically, according to modern science, we are on a ball Earth, and the stars, the closest star, let's see, closest star, the stars are like supposed to be really far away from us, and we're spinning around the sun, and we're spinning around ourselves on the Earth, and then the Earth is spinning around the sun, and the closest star to us is going to be Alpha Centauri, and that's 4.367 light years. Oh, says Proxima Centauri is 4.2 light years. So between 4.2 and 4.4 light years away. So a light year, as you may or may not know, is the distance that light travels in 1 year. So it's not a unit of time. Like we say a light year, it's not like a year on the calendar. It's a distance. So a light year represents the speed of light times basically the distance an object would travel if moving at the speed of light for the time duration of 1 year. So it's a complicated way of saying it. Basically, it's a way of measuring the distance. So it basically is saying that at the speed of light, if you were traveling at the speed of light, which is the fastest you're supposed to be able to move in the universe, we're going to talk about that in a second. Then it would take 4.2 to 4.4 years at the speed of light to get to one of these stars. So obviously super, super far away. I'm sure if anybody who's like studied this, we understand the effects of gravity diminish over distances. So for instance, when the astronauts went to the moon, we got footage of them walking on the moon, and they moved with a different gravity movement, right? Like there was less gravity on the moon because they're far enough from the Earth that they're no longer experiencing the gravity from the Earth. So we understand that gravity over distances diminishes. So the gravity of the Earth is no longer in effect even measured. Basically, it's no longer noticeable by the time you get to the moon, and the moon's far less than a light year away. It's measured in thousands of miles or millions of miles, I think. In fact, we did, what was it? How far is the moon? It's like 100 something. But anyways, so we understand these stars are incredibly far away, like by magnitudes, volumes, and we know obviously that the stars are not connected gravitationally to the Earth. So we assume the idea has been, according to current science, the current modern mainstream scientific view, the Earth revolves around the sun because gravity holds it to the sun. But we also know, and this is the next thing we're going to talk about, we also know that the constellations revolve around the Earth. And so that's so crazy. But it's not by gravity, right? Because they're obviously 4 point something light years away. So they're hundreds of billions of miles away. Like they're super, super far. So it's not a gravitational, we know for a fact the constellations are not gravitationally linked to the Earth, unless they're way closer than we're told. If they're 4 point something light years away, they're not gravitationally linked to the Earth, according to science, according to the measurements of science. Now, what's interesting that brought up, when I realized that, when that clicked for me, I was like, oh, whoa, why are the constellations there? Why do they exist? Why haven't they moved over time, right? And I remember, so that's an interesting question. I posed it to science people before, and the answer that you always get is that they do move, just over such a long period of time, and they're so far away that even though they move, it's unnoticeable. So you don't see it for thousands of years, right? So I thought, okay, that seems pretty reasonable, like a pretty reasonable thing, because they are, like we just talked about, 4 point something light years away. So you just wouldn't see the angle of change. But if you start, okay, so I guess, okay, we're gonna leave it at that. I'm gonna do one more break, and then we're gonna talk about the problem with that. I'll be right back. Okay, we're back here. Now, this is something that I don't have. This whole section, we don't have a precedent. I think that if this is basically, I'm going to present a hypothesis to you in this third section, because no one else has done research on this topic. I can't refer to someone else. I can't rely on somebody else's research on this. So what I get to do is propose the question to you guys and let you answer it for me. So this is an open question I offer for anybody to answer. We know, like I talked about earlier, we know that nothing in the universe is supposed to be able to travel. There's this idea that nothing in the universe can travel faster than the speed of light. However, that's not really the case. There's an exception to that rule that anybody who knows anything about the subject can tell you, and it has to do with the fact that with something called relativity. So we know that speeds are relative because you may be traveling at the speed of light relative to the Earth. So if something takes off at the speed of light relative to the Earth, then it's going the speed of light relative to the Earth, obviously. But if something else took off at the speed of light in the same exact direction from the speed of Earth at the same time, then those two objects would be traveling at 0 miles per hour relative to each other. So we know that relativity can essentially can and does defy the laws of relativity. And we know for a fact that, for instance, the star, like we know that since we're moving around in space, there's nothing, unless science is wrong, right? According to current scientific theory, the Earth and the Sun, like our galaxy, for instance, we're not locked into this place. We're just floating in space. It's relative. Our position is relative to other things. It's not a fixed location. Like the Sun is not attached, according to modern science, the Sun is not attached to a pole in space that's attached to the ether of space or something. We're just out there in space, and our position is only relative to the other things out in space. So with that said, we know for a fact that this same thing is true about every other galaxy. So every other solar system, every other star is also moving at a relative speed compared with other objects. And we know for a fact that that is often what happens is it essentially creates a faster than light speed travel, because a star, like a star system, the Alpha Centauri, for instance, could be moving west relative to the Earth, in a due west direction at at a certain speed, let's say half the speed of light. And we know that the Earth could be moving at 3/4 the speed of light relative to that system, to the Alpha Centauri system, in the opposite direction, heading east. And if you compare the two objects, you can tell you would measure a speed, a relative speed greater than the speed of light. So we know for a fact that, according to modern scientific theory, all objects in the sky are moving at random in random directions at faster than light speed travel over thousands of years. And yet we're told that the constellations are revolving, and there's zero measurable distance of alteration in those constellations over literally tens of thousands of years. We have records of those constellations from tens of thousands of years ago, from the earliest civilizations. We have this stuff carved into church, religious sites, like into caves. Like, it just goes back. The constellations go as far back as history, and there's no measurable degree of change between these stars that, according to modern scientific theory, are moving away from each other at in random directions at faster than light speed travel. If you're the theory that the constellations are moving, but only at an undiscernible rate, is based on the theory that they're moving at under light speed travel. But if they're moving at faster than light speed travel, then at that point we would begin to see a difference. You'd be able to physically see and measure change over time. So yeah. Now I think that's interesting. I think it's interesting that there was foresight, because it seems like there's almost no other reason to have the existence of a constellation. Like, they don't serve purposes. They have like story pieces to them, but there's nothing about the constellations that really do, they're just sort of there. And yet every culture has kept them. So I'm just going to leave this last point, and I believe, I'm a Christian, and as a Christian I believe in the Bible, and I believe that the author of the Bible is God, and I believe that everything that God put into the Bible was put there for a really good reason. So, and I think He told us that the constellations were there for signs, that He put them in the sky as signs for us. And I thought about that a lot, and when I realized what constellations show us about the nature of our environment, and the foresight that it would have taken to foresee, to basically have put this I think it's incredible to put this together. The foresight to know that we would have gotten off track, I guess, or whatever, however you want to look at it. And then to point out, to keep track of something like the constellations, I think is pretty interesting. Again, if anybody wants to challenge or rebut, I would love to do a show with anybody who wants to show the evidence that that the constellations would still be unnoticeably changed tens of thousands of years later, given what we now know about relative faster than light speed travel. Feel free to send me an email at fearofaflatearthradio@gmail.com. I don't get a lot of emails challenging a lot of these shows, to be honest, and I hope it's an open enough platform, and I hope you guys feel comfortable. Yeah, and I'd love to discuss it with anybody on a later show. So yeah, I know I got a lot of awesome listeners, and you guys are great, and yeah, I just appreciate the ear too. So you guys have a great holiday, and yeah, take care. We'll see you next time.
Hello. Howdy, howdy. Say again?